Hi, welcome to my poster site. My name is Edgar Ikure. I'm a biomedicine PhD student with an interest in glaucoma research. My current primary interest is on evaluating the efficacy of letrozole and bimatoprost on IOP control and how they influence the biomechanical properties of the cornea in open angle and normal tension glaucoma. In this study, we looked at the association between corneal hysteresis and structure function parameters. Specifically, we looked at visual field mean deviation, visual field index, vertical CD ratio, and average retinal nerve fiber layer. This was a retrospective study of 140 subjects. One reason I decided to create a video of my presentation was because the plots on my posters were not too clear. So take your time and go through the slides at your pace, but I'm going to briefly breeze through them. Why should you care about this research? Glaucoma is the second leading cause of blindness worldwide, and about 60 million people worldwide have glaucoma. That number is projected to reach 110 million by the year 2050. Measuring corneal hysteresis may help diagnose glaucoma earlier and monitor for possible progression. In this research, we report evidence that a 1 millimeter reduction in corneal hysteresis may result in about 63% increased risk of glaucoma. We also present evidence that corneal hysteresis could help us increase our prediction of glaucoma. Table 1 here shows the demographic characteristics of subjects and summary statistics. I'm not going to go into every detail. I urge you to go through them at your pace, look through them, and give us your feedback. Figure 1 shows box plot of frequency distribution of the visual field index, that's A, IOPCC, or the corneal compensated intraocular pressure, that's B, central corneal thickness is C, corneal hysteresis is D, visual field mean deviation is E, and average retinal nerve fiber layer is F. Again, so go through the slides at your pace and give us your feedback. Figure 2 is correlation plots for all the variables we're interested in. The first is an association plot between age and corneal hysteresis. The second tab is corneal hysteresis versus corneal compensated intraocular pressure, and we can see the nice negative correlation there. There is corneal hysteresis and average retinal nerve fiber layer. We also have corneal hysteresis and visual field index, and corneal hysteresis and visual field mean deviation. This is a correlation heat map of all the variables we collected. You can go through them also. Figure 4 is a correlation plot for each group. In this study, we looked at 3 groups. We looked at normal, we looked at ocular hypertension, and we also looked at open angle glaucoma. This figure 4 shows the correlation plot for each of those groups. Green, the red is for normal subjects. Green is for ocular hypertension, and blue is for open angle glaucoma. This is a table that shows the unadjusted and the adjusted odds ratio. The most important is the odd ratio for corneal hysteresis. The odd ratio here is 0.614, which means that a 1 millimeter increase in a 1 millimeter mercury increase in corneal hysteresis will result in about 39% decrease in the risk for glaucoma. Conversely, it also shows that a 1 millimeter mercury decrease in corneal hysteresis will result in about 63% increase in the risk of developing glaucoma. And figure 5 shows plots of the area under the curve, AUC plots, and B shows an AUC of 0.75 or 75% of distinguishing between normal subjects from glaucoma subjects. Thank you for your interest in our research. We welcome your suggestions, we welcome your critiques, and we're also open to collaborating with you. Thank you.